So we have two polar coordinates. We have r theta sub 1 and then r comma theta sub 2. We have for sub 1 2.00 meters times, or rather 2.00 meters, comma 50.0 degrees. For our second one, we have 5.00 meters, comma negative 50.0 degrees. So we can then say that our x sub 1, y sub 1, x sub 2, y sub 2. X sub 1 would be our r, 2.00 meters, 2.00 meters. For our x sub 1, it would be cosine of 50 degrees. Here it would be sine of 50 degrees, and we're doing the exact same thing for x sub 2. So this would be 5.00 meters, again 5.00 meters, cosine of negative 50 degrees, and then sine of negative 50 degrees. So here, x sub 1 is equaling 1.29 meters. Y sub 1, 1.53 meters. X sub 2, 3.21 meters. Again, remember that cosine is an even function. So cosine of negative 50 degrees becomes cosine of 50 degrees times 5 meters. 5 meters times sine of negative 50 degrees. Sine is an odd function. So this actually becomes negative 5.00 meters times sine of 50 degrees. So here we have essentially negative 3.83 meters. So we can say that then the distance between the 2 points would be essentially, we could say delta S would be the distance. So this would be equaling the square root of the change in the x position squared plus the change in the y position squared. And then take the square root of the sum. And so we can find delta S. This would be equaling the square root of, this would be 1.29 meters minus 3.21 meters quantity squared plus 1.53 meters minus negative 3.83 meters quantity squared. Extend the square root, and we find that the distance between the 2 points is equaling 5.69 meters, rounded to 3 significant figures. This would be our final answer. That is the end of the solution. Thank you for watching.